Okay, let's get an introduction to vector projections here. I won't show you how to calculate a projection vector. I will simply motivate the ideas of understanding vector projections, and then you could use some basic trigonometry to actually calculate the vector, and I'm sure I've got videos on those floating around there somewhere too. So the first thing is, you may see something like calculate the projection of vector u, which might be given to us in some sort of component form here. Sorry about that pop-up. Calculate the projection of vector u onto some other vector v, which could also be given in its component form. Okay? So just to give you the framework for what we'd be doing here. Now, the projection of u onto v, what that really maybe is saying, the way to think about it is, if you're projecting onto v, that is basically going to act as an axis that we will project this vector onto. Okay? And when we project a vector, it's at a 90-degree angle. So let's see what's happening here. Let's say that vector u looks like this, and let's say that vector v looks like this. So this is vector u on the top, and this is vector v on the bottom. So what we do is we pretty much ignore vector v for now, except we think of it like an axis, like an x or a y axis basically. And of course it goes forever in both directions. And then we simply take our vector u and project it at a 90-degree angle onto that axis. And we end up with this sort of thing. Now notice the setup here. Vectors u and v both started at this same point. They have the same initial point. Okay? So once we've projected u onto the v axis, then what is the projection? Well, the projection, you could probably imagine, is this piece down here. Okay? It's sort of the image of u on the v axis. Now, one other thing to realize, the projection is itself a vector. Okay? So this piece that I've got down here currently is not a vector. So how do I turn it into one? Well, I simply give it a direction. So my vector is going to be pointing this way. So my vector, my projection vector, has the same starting point as u and v, and it ends at the tip of this actual projection of u onto the axis. Okay, so that's pretty interesting. Now, a way to name this vector, this is the projection vector. Of u onto v. And notice the u and v vectors that I drew were random. Okay, it was just an example. So they would be given to us in component form up here somehow, okay, if we were actually working a problem. Now, this is cumbersome to write. Projection vector of u onto v. So we have a notation that we use, and we use the proj for projection, and then leave a space, the projection of u, and so that's on the same level as the word proj, the projection of u onto v. So we're going to put a subscript of v down here between the two. So the projection, subscript v, u. And so that's the projection of u onto v. So the one that's the subscript, that's your axis vector. Okay? The one you're projecting onto. Alright, great. Now, let's look at this again. Say this is u, and this is v. Well, notice that my v-axis is still the same. So if I was projecting u onto v again, I would get the exact same vector as I did before. So if my axis is the same, independent of the vector, then my projection will be the same. Also, if this was u, and now this is v, my axis is the same once again. My vector v points in a different direction, but my axis is the same, so my projection vector will be the same again. Okay? Alright, so to get a projection vector, you make an axis out of the vector you're projecting onto, and then you form a 90-degree angle between the other vector and your axis. The vector that lives on the axis is your projection vector. Okay? And it makes sense why it's called projection, right? If you were to shine a flashlight, I don't know why I'm drawing this. If you were to shine a flashlight at a 90-degree angle to the axis, you would cast a shadow from this vector onto that axis, and that would be the projection of u onto v. Now, let's look at this picture one more time, the same exact picture, so let me erase this. Let's say, instead of all of that, sorry that didn't erase, let's use the same vectors u and v that I had in my pictures, but now, I don't want to give you the wrong idea, what if I wanted to calculate the projection of v onto u? Okay? Now, I'm not actually calculating in this video. Again, I'm just motivating the idea. But I would join vectors u and v the same way I did before at the initial points. But now, so this is vector u, this is vector v. Now, my axis is my u vector. So maybe I need some more room here. My axis is my u vector. So I'll extend it so I can think of it as an axis rather than a vector. And then I need to form a 90-degree angle from the tip of vector v onto this axis. And so I simply form a 90-degree angle with that axis. And my projection vector lives on that axis, starting at the same initial point as u and v. And it points towards the end of that projection, which is right here. So this purple guy or pink guy here is my projection of v onto u. Alright, so I hope that makes sense. You can probably see that you can start to use some basic vector and right triangle trig to actually calculate that vector, and you can probably search my videos and find another one for that. Thank you.